Bubble sort takes over 800 comparisons to sort 30 elements. Merge sort does it in under 150. Same array, same result. Watch why. Here is an unsorted array. Merge sort does something completely different from every algorithm we have seen so far. It does not compare adjacent elements. It does not pick a pivot. Instead, it does this. It splits the array in half, then splits each half again, and again, all the way down until every element is completely alone. A single element is already sorted by definition. That is the insight everything else is built on. Now watch the magic happen in reverse. Merge sort starts combining those single elements back together, but this time in sorted order. Two sorted groups of one merge into a sorted group of two. Two sorted groups of two merge into a sorted group of four. Watch those golden bars. That is the merging happening in real time. Each combination is perfectly ordered because merging two already sorted groups is trivially easy. Just compare the smallest from each side and take the smaller one first. See how the sorted sections grow. Small sections become larger sections. Larger sections merge into even larger ones, until the entire array is done. Bubble sort needed 800 comparisons. Merge sort needed 147. That is the difference between O(n) squared and O(n) log n. And watching it happen makes it obvious why. The one trade-off: merge sort needs extra memory to hold the temporary arrays during merging. That is the price of that speed. Divide, conquer, merge. One of the most elegant algorithms ever written. Merge sort changed how programmers think about sorting. But another algorithm takes a completely different approach and becomes even faster in practice. That algorithm is quicksort.